500,000 people go about their lives every single day directly on top of a sleeping giant, and most of them barely think about it. We are talking about the city of Naples in the south of Italy, one of the most densely packed urban regions anywhere in Europe. Walk through it, and you will find centuries-old churches, narrow cobblestone streets, balconies dripping with laundry, and restaurants serving some of the best food on the continent. It feels timeless, almost impossibly ordinary. But underneath all of that ordinary life sits one of the most unpredictable geological structures on the entire planet, and lately it has been showing signs that it is far from finished. Most people who live in and around Naples have known about this danger for generations. It is not a secret. It is simply something they have learned to live beside, the way people learn to live beside a difficult relative or an old family debt that never quite gets paid off. For decades, that giant seemed slow, sluggish, almost too lazy to actually cause trouble. But that old assumption might be changing right now, in real time, and the reasons why are worth understanding properly. The name of this place is Campi Flegrei, which translates roughly to the burning fields. It is not a single mountain with one obvious crater sitting on top like a postcard image of a volcano. Instead, it is a caldera, a vast, collapsed volcanic system stretching across roughly 13 kilometers, most of it hidden beneath the ground and beneath the sea itself. The town of Pozzuoli sits right on top of the most active section of this entire structure, which is a strange thing to sit with if you actually stop and think about it. Families raising children, running shops, going to school, directly above ground that has a documented history of violent upheaval. To be fair to the region, the last truly major eruption happened all the way back in 1538. And the last time the system caused an actual continental catastrophe was roughly 39,000 years ago. That eruption was so enormous that some researchers believe it contributed to the decline of Neanderthal populations across the whole of Europe. It pumped enough material into the atmosphere to cool the global climate and physically reshape landscapes across the continent. That is simply a reference point, a way of understanding the raw scale of what this system is capable of when it truly lets go. For the last several decades, scientists monitoring Campi Flegrei were focused primarily on one threat: rising magma. The logic was straightforward. Magma rises from deep below, pressure builds beneath the surface, and eventually the ground gives way, resulting in an eruption. Scientists tracked this using familiar warning signs, things like ground deformation and gas emissions escaping from vents. And for as long as anyone has been carefully measuring the area, Campi Flegrei has displayed these signs in repeating cycles, including visible changes to the ground itself in and around Pozzuoli. The earth there has physically risen and fallen by meters over the past century. Earthquakes strike the region regularly. Scientists refer to this phenomenon as bradycism, the slow, rhythmic rising and falling of ground above an active volcanic system. For a long time, researchers believed they understood this process reasonably well. Then two new scientific studies emerged, one published in 2023 and another in 2025, and together they completely changed the picture. It turns out that rising magma is not the only danger lurking beneath this region. Something else has been quietly building underneath Pozzuoli, something that scientists, despite years of careful monitoring and sophisticated modeling, had missed entirely. Understanding what they eventually found requires a completely different mental model, one that has nothing to do with a mountain building toward an eruption in the traditional sense. Picture a pressure cooker sitting on a stove. Water is sealed inside. The lid is locked shut. And as heat is applied, thermal energy keeps climbing higher and higher. The water inside becomes superheated because the sealed environment will not allow it to simply turn into steam and escape into the open air. This is exactly how pressure builds inside a sealed container. As long as that lid holds firm, nothing dramatic happens. But the moment the lid finally fails, everything that has been trapped and compressed releases all at once, violently without warning. This, according to the newer research, is essentially what is happening right now underneath the city of Pozzuoli. Scientists had not fully appreciated the existence of a natural sealing mechanism in the rock sitting above the hydrothermal system beneath the town. Superheated water and steam have been quietly accumulating under enormous pressure for years, but the rock layer above it keeps sealing itself back up, almost like a wound that keeps closing before it can properly drain. Sometimes the mounting pressure cracks that rock open, creating a gap. Hydrothermal fluid then floods into that gap. As the fluid cools, the cracks seal shut again, the lid repairs itself, and the pressure resumes building beneath it. This repeating cycle of cracking and resealing is now believed to be the actual cause of many of the earthquakes striking the region, not simply magma pushing its way upward as previously assumed. Then the 2025 study pushed the investigation even further. Researchers used artificial intelligence to analyze enormous quantities of seismic data collected from the region. In doing so, they identified something previously hidden beneath the hydrothermal system. Entirely. A ring fault, a circular fracture structure sitting underneath Campi Flegrei. This ring fault could potentially allow for a much larger and far more sudden release of pressure than the slow, gradual cracking and sealing cycle that had already been observed. In plain terms, the ring fault represents something close to a worst-case scenario hiding inside a system that scientists were already worried about, and it went completely unnoticed for decades of careful observation. So what does any of this actually mean for the roughly 500,000 people living directly on top of this system? The honest answer is that nobody knows for certain. These new studies did not predict a specific eruption. What they did was clarify the underlying mechanism happening deep underground and reshape how experts think about the overall risk. The pressure cooker model essentially tells us that magma reaching the surface is no longer the only concern worth watching. We now also need to worry about the ongoing cracking and sealing process, and about the pressure quietly rising beneath it, independent of whether magma itself is moving at all. The uncomfortable truth researchers are grappling with is this: the system could theoretically reach a breaking point far faster than existing evacuation plans are designed to handle. And crucially, nobody on Earth has ever had to manage a situation quite like this before. There is no established playbook for a sealed hydrothermal system slowly building pressure directly beneath a living, breathing city of 500,000 residents. This is not a problem that has already been solved somewhere else and can simply be copied and applied here. This is genuinely new territory for volcanology and for civil planning alike. The Italian government has, to its credit, already prepared civil protection plans for a potential emergency. Formal evacuation protocols exist on paper. The surrounding area has been divided into red, yellow, and green zones based on proximity to the most active parts of the system. When seismic activity increases significantly, residents living in the red zone are instructed to be ready to leave on short notice. People in the region know which zone they live in. That system exists, documented and rehearsed. But the pressure cooker model raises an uncomfortable question that hangs over all of that planning. What happens if the actual warning window turns out to be shorter than anyone has planned for? It helps to zoom in for a moment and understand what Bradyisms actually looks like from ground level, from the perspective of someone simply living their life in Pozzuoli. This is a working port city. It has markets, restaurants, apartment buildings, schools, ordinary daily rhythms, just like anywhere else. But it also has ancient Roman ruins scattered throughout, and one structure in particular tells an extraordinary story. The Macellum, an old Roman marketplace sometimes referred to as the Temple of Serapis, displays clear physical evidence of the ground repeatedly rising and falling over many centuries. Marine organisms bored holes into the marble columns at specific heights, marking where sea level once stood relative to the structure at different points in history. Those marks form a kind of geological record written directly into stone, sitting in the middle of a modern city, silently documenting the rhythm of a system that has been doing this for thousands upon thousands of years. For the people actually living in Pozzuoli, earthquakes have become something close to a normal part of daily life. The ground rises, the ground falls, buildings develop cracks and get patched up again. Some residents have chosen to leave the area entirely over the years, unwilling to keep gambling on stability. But many others have stayed, bound to the place by deep personal history, by family, by community, by the simple practical difficulty of picking up an entire life and relocating somewhere else. All of these very human, very understandable reasons keep people rooted in a zone that scientists are now examining with a fresh and urgent sense of concern. Let's look at some actual numbers, because they matter here. Since 2022, the rate of ground uplift in the region has noticeably accelerated. Earthquakes have grown more frequent as well. In September of 2023, a magnitude 4. 2 earthquakes struck the area, the strongest the region had experienced in 40 years. It was powerful enough to send thousands of frightened residents pouring into the streets in the middle of the night. Bradyism itself is nothing new to this region, but the pace at which conditions are now changing very much is. Researchers today are increasingly less focused on the simple question of whether Campi Flegrei will eventually erupt, and more focused on a harder question: whether the system is approaching a point where the pressure cooker metaphor stops being a useful metaphor altogether and instead becomes a literal, accurate description of an irreversible process, one that could spell catastrophe for the local community living directly above it. To be balanced about all of this, it is worth genuinely listening to what many volcanologists are saying. They correctly point out that Campi Flegrei has passed through intense periods of unrest before, without ever actually erupting. Consider the 1970s and 1980s, when the ground in the region rose by nearly 2 meters. Tens of thousands of people were evacuated as a precaution during that period, and in the end, nothing happened. No eruption came. The region eventually settled back down. The important caveat, though, is that those earlier episodes of unrest were not fully understood at the time using the pressure cooker mechanism, because that mechanism simply had not been identified yet. The ring fault had not been discovered either. Scientists back then were working from an incomplete picture of what was actually happening beneath their feet. And the incomplete picture they did have suggested that the system could absorb a significant amount of stress without ever rupturing. Today, researchers understand that the true picture is considerably more complicated than that older model allowed for. The presence of a sealed hydrothermal system fundamentally changes the underlying math of the whole situation. And the acceleration in both ground uplift and seismic frequency observed since 2022 is happening at rates that do not have a clear precedent anywhere in the modern monitoring record for this particular volcanic system. Sit with that for a moment. 500,000 people, and a pressure cooker mechanism that scientists themselves only fully came to understand within the past few months, relatively speaking. Nobody has ever had to manage a scenario quite like this one before, and nobody can say with total confidence exactly how it ultimately plays out. Now, it is worth stepping outside of Italy for a moment, because Campi Flegrei is far from the only slumbering giant that scientists are currently keeping a close eye on around the world. There is an old volcano tucked away in Bolivia called Uturuncu that has not erupted in roughly 250,000 years. On the surface, that sounds like the definitive end of its story, an ancient relic with nothing left to say. But recently, it has started behaving a little strangely, almost like something stirring after an extraordinarily long nap. Uturuncu is an enormous mountain situated in the Andes, standing nearly 20,000 feet tall. It belongs to a category known as a stratovolcano, meaning it is large, steep-sided, and built up in distinct cone-shaped layers over long stretches of geological time. These particular kinds of volcanoes are constructed from repeated layers of hardened lava, ash, and rock debris. They are capable of producing terrifying, powerfully explosive eruptions precisely because their lava tends to be thick and viscous, trapping gas inside rather than allowing it to escape smoothly. Picture a shaken soda bottle just moments before someone finally twists off the cap. Famous volcanoes like Mount Vesuvius share the same general classification as Uturuncu, and everyone remembers the tragic fate of Pompeii, utterly destroyed during that infamous eruption of Vesuvius nearly 2,000 years ago. Could something similar be waiting to happen in Bolivia? Even though Uturuncu has remained quiet for an extraordinarily long stretch of time, scientists monitoring the mountain have noticed it releasing gas, rumbling with small earthquakes, and even causing the surrounding ground to visibly bulge outward, almost as though the mountain itself were stretching after a long period of dormancy. Naturally, this activity got people wondering whether the volcano might be gearing up for another eruption after all this time. Researchers decided to investigate the situation more closely, and what they discovered was that liquid and gas moving beneath the volcano was responsible for generating all of this surface activity. That finding does not necessarily mean the volcano is definitely preparing to erupt, but it does help explain why Uturuncu still appears, in a sense, very much alive despite its long silence. Let's walk through the details a bit further. Since the 1990s, scientists have relied on satellite imagery and GPS measurements to closely monitor the ground surrounding Uturuncu. At a certain point, they noticed something distinctly unusual. The ground in the very center of the region was rising, while the ground around the outer edges was simultaneously sinking, creating a shape somewhat resembling a wide-brimmed sombrero hat. That central area has been slowly rising for at least 50 years, at a rate of roughly 4 millimeters annually. On its own, that number does not sound like very much at all, but combined with everything else being observed, it starts to paint a more concerning picture. This unusual sombrero-shaped deformation, paired with countless tiny earthquakes and carbon dioxide gas seeping out of the volcano, led some scientists to initially suspect that a large blob of magma might be steadily growing beneath the mountain. If that theory turned out to be accurate, it could point toward only one genuinely alarming possibility, that the volcano was quietly preparing itself for an eventual eruption. Uturuncu sits directly above a massive underground reservoir of partially molten rock known as the Altiplano Puna magma body. This reservoir is enormous and extraordinarily deep, stretching beneath portions of Bolivia, Chile, and Argentina all at once. Scientists initially theorized that magma from within this vast reservoir might be gradually rising and accumulating closer to the surface, potentially setting the stage for an eruption somewhere down the line. But now, after carefully studying more than 1,700 individual earthquakes recorded in the region and closely examining rock samples collected around the volcano, scientists have arrived at a different explanation. It appears that magma itself is not actually rising toward the surface after all. Instead, hot fluids and gases are traveling upward from the deep magma reservoir through a narrow pathway shaped somewhat like a chimney. Gases, such as steam and carbon dioxide, can become trapped just beneath the summit of the volcano, while salty water, known as brine, spreads sideways into countless tiny cracks within the surrounding rock formations. This ongoing movement of gas and fluid is enough on its own to cause the ground to rise and fall and to trigger small earthquakes, all without any actual magma needing to approach the surface. So the encouraging news here is that Uturuncu likely is not on the verge of an imminent eruption after all. If a major eruption did somehow occur, it would undoubtedly cause serious damage to nearby communities and pose a genuine threat to human life in the surrounding region. Lava flows could potentially travel tens of miles from the volcano itself, and volcanic ash could spread widely across Bolivia, Argentina, and Chile simultaneously. Fortunately, even though the volcano remains active and continues to rumble beneath the surface, it appears considerably less dangerous than scientists had originally feared. This particular discovery may ultimately help researchers determine whether other seemingly dormant volcanoes around the world could be exhibiting similar warning signs without actually approaching eruption. Shifting focus now toward Alaska, researchers there have been closely watching Mount Spur, which some believe could potentially erupt in the relatively near future. The volcano has been releasing unusual quantities of volcanic gas from both its summit and a side vent, the very same vent responsible for its last documented eruption back in 1992. Should it erupt again, the consequences could create serious complications for aircraft flying through the region, along with volcanic ash potentially falling from the sky over nearby areas. The reassuring part of this particular story is that essentially nobody lives close enough to Mount Spur to be in immediate physical danger, meaning that even in the event of an eruption, the population risk remains relatively low for now. Even though Mount Spur itself is not considered especially dangerous to human populations, plenty of other volcanoes scattered around the globe carry the potential to be genuinely destructive. Campi Flegrei, the very system discussed at length earlier, sits right at the top of that list, situated near the city of Naples. Rather than featuring one single prominent mountain, the entire system contains roughly 24 separate craters spread out across the wider area. As already covered, it last erupted back in 1538, though its most catastrophic eruption occurred roughly 40,000 years ago. That ancient explosion blanketed the entire Mediterranean region in volcanic ash and caused regional temperatures across Eastern Europe to drop by as much as 16 degrees Fahrenheit, ushering in a lasting volcanic winter across the continent. Should Campi Flegrei erupt again in the present day, the consequences could be extremely severe. It could potentially bury Naples and the surrounding communities beneath layers of volcanic ash, triggering earthquakes and landslides, along with significant air pollution and acid rain across the region. Scientists continue monitoring the area extremely closely, particularly following a magnitude 4 earthquake that shook the region back in March of 2025. The reassuring detail, at least for now, is that there is currently no clear sign of magma actively rising toward the surface, which suggests an eruption is not considered imminent at this particular moment. Still, given how volcanically active Italy is as a whole, experts continue watching the situation with considerable care and attention. Mount Vesuvius, also located in Italy, remains one of the most famous volcanoes anywhere in the world. It is best known for its catastrophic eruption in 79 CE, which completely buried the Roman cities of Pompeii and Herculaneum beneath thick layers of ash and pumice, freezing an entire moment of daily Roman life in place for archaeologists to eventually uncover centuries later. Vesuvius most recently erupted back in 1944. Today, the volcano is considered even more dangerous than in previous eras simply because of population growth in the surrounding region. More than 3 million people now live in reasonably close proximity to the mountain, and roughly 700,000 of them are living illegally directly on its slopes, placing them at even greater risk than the general population nearby. Should Vesuvius erupt again, it could send rocks and ash hurtling through the air at speeds approaching 100 miles per hour, causing major destruction and potentially devastating large portions of Naples itself. That said, scientists currently believe that a major eruption from Vesuvius is unlikely to occur for at least several hundred more years. Nevertheless, because it remains an active and closely watched volcano, researchers continue monitoring it on an ongoing basis. Cumbre Vieja is a volcano located on the island of La Palma, part of Spain's Canary Islands. It most recently erupted back in 2021. During that particular eruption, molten lava poured steadily out of the volcano and flowed all the way down to the sea, ultimately destroying more than 3,000 homes along the way. Fortunately, thousands of residents were safely evacuated ahead of time, which meant the overall human toll ended up being far less severe than it otherwise could have been. In previous years, some scientists expressed concern that a sufficiently large eruption could cause the entire western flank of the volcano to break away and collapse into the surrounding ocean. Such a collapse could theoretically trigger a massive tsunami, sending enormous waves potentially hundreds of feet high racing across the Atlantic Ocean toward distant coastlines. However, more recent scientific studies have concluded that this particular catastrophic scenario is very unlikely to actually occur. Mount St. Helens, located in Washington State in the United States, experienced a massive and infamous eruption back in May of 1980, an event that tragically claimed the lives of 57 people. That eruption also triggered the largest landslide ever recorded in documented history, Hot, pressurized magma violently exploded outward from the volcano, launching ash roughly 15 miles into the sky above. The resulting ash cloud blanketed a vast area, and approximately 230 square miles of surrounding land were ultimately destroyed by the eruption's force. Mount St. Helens remains active today and is expected to erupt again at some point in the future, potentially even within our own lifetimes. However, experts generally believe another massive sideways blast similar to the one witnessed in 1980 is now considered less likely, largely thanks to the deep crater structure that has since formed at the summit, which is expected to fundamentally alter how any future eruption unfolds. Finally, Popocatépetl stands as a large, consistently active volcano located in Mexico. It has been erupting intermittently, on and off, since the early 2000s. What makes it particularly concerning is its close proximity to an enormous number of people. It sits just 40 miles from the greater Mexico City metropolitan area, home to roughly 22 million residents, and about 30 miles from the city of Puebla, home to approximately 6 million people. Should Popocatépetl experience a truly massive eruption, it could potentially blanket Mexico City in a thick layer of volcanic ash as much as 8 inches deep. That kind of ash accumulation could clog drainage systems, contaminate water supplies, and even disable electrical infrastructure across the affected area. Even more dangerous, fast-moving lava and superheated pyroclastic flows could rush directly down the mountainside, destroying nearby towns in their path. The volcano remained largely quiet for roughly 50 years, but it now rumbles and shakes with noticeable regularity. It has produced more than a dozen smaller eruptions in recent years, including some as recently as February of 2024. Some nearby communities have found themselves lightly dusted in ash from these events, though scientists note this isn't especially surprising given the volcano's current level of activity, and they continue monitoring the situation closely. Taken together, these stories from Naples to Bolivia, from Alaska to Mexico, paint a picture of a planet that is anything but geologically settled. Beneath quiet mountains and sleepy coastal towns, enormous systems continue to shift, breathe, and reshape themselves on timescales that dwarf a single human lifetime. Campi Flegrei remains the one to watch most closely right now, not because an eruption is guaranteed or even necessarily imminent, but because scientists themselves only recently uncovered the true mechanism driving the unrest happening beneath 500,000 people's feet. That alone is reason enough to keep paying attention. What makes Campi Flegrei different from almost every other case on this list is the sheer intimacy between the hazard and the population sitting on top of it. Utrunchu is remote, tucked away high in the Andes, far from any major city. Mount Spur sits in a stretch of Alaska where almost nobody lives, close enough to be directly threatened by lava or pyroclastic flow. Even Popocatépetl, as close as it sits to tens of millions of people, has a summit that towers far above the valleys where those people actually live, giving distance a chance to work in everyone's favor. Campi Flegrei offers no such buffer. Pozzuoli isn't near the hazard. It sits directly on top of it. The market stalls, the apartment blocks, the schoolyards, all of it exists in the same physical space where superheated fluid is quietly pressing against a sealed rock ceiling somewhere below. That proximity changes the entire calculation for civil planners. In a place like Mexico City, distance buys time to issue warnings, time to organize transportation, time to move people out of the most immediate danger zones before conditions worsen. In Pozzuoli, that same luxury of distance simply does not exist in the same way. If the ring fault identified in the 2025 study were ever to behave the way researchers now think it theoretically could, the interval between a clear warning sign and an actual event might be measured in a time frame far shorter than anyone has built into existing evacuation planning. This is precisely why the newer research matters so much. Not because it hands anyone a countdown clock, but because it forces planners to reconsider what a genuinely adequate warning window even looks like when the hazard sits directly beneath the community it threatens. It's also worth remembering that scientific understanding of a system like this rarely arrives all at once. For decades, the working theory around Campi Flegrei was built almost entirely around magma movement, because that was the mechanism scientists could most directly observe and measure using the tools available to them at the time. The hydrothermal sealing process stayed hidden not because nobody was looking, but because the tools required to detect it, extensive fault mapping, dense seismic networks, and eventually machine learning models capable of parsing enormous volumes of tremor data, simply did not exist in earlier decades. The ring fault in particular is the kind of structural feature that likely would have remained invisible without the specific combination of artificial intelligence and years of accumulated seismic recordings feeding into the 2025 study. In that sense, this entire episode is also a reminder that the ground beneath even the most heavily studied places on Earth can still hold surprises, and that vigilance has to evolve alongside the tools used to maintain it. None of this means panic is the appropriate response. The scientists studying Campi Flegrei have been careful and deliberate about not overstating what they actually know. An eruption has not been predicted. A timeline has not been announced. What has changed is the depth of understanding around a mechanism that was previously invisible. And with that deeper understanding comes an obligation to reassess old assumptions, rather than simply reassure people that everything happening now looks just like it did in the 1970s and 1980s. It might, or it might not. And for the first time in modern memory, scientists studying this particular volcanic system are genuinely uncertain which of those two outcomes is more likely, which is itself a kind of honesty worth respecting rather than fearing. For the 500,000 people who call this region home, life continues, much as it always has. Markets open in the morning, fishing boats leave the harbor at Pozzuoli, children walk to school past Roman ruins that have quietly recorded the rhythm of this restless ground for thousands of years. Most residents have made peace with the uncertainty in the same way people everywhere make peace with living near rivers that flood, coastlines that erode, or fault lines that occasionally shake the walls of their homes. It is simply the price of living somewhere beautiful, historic, and geologically alive. The difference now is that the science watching over them has finally caught up to at least one of the mechanisms working quietly beneath their feet, even if it hasn't yet answered the one question everybody actually wants answered: when, if ever, this particular giant finally decides to stir